Welcome to my free Java video course, Lesson 10. My name is Markus Biel. In this tutorial, I would like to introduce you to enums. Enums in Java represent an enumeration, so they enumerate something. They were introduced in Java 5. More about this very soon. First of all, let's recap what I showed you in the last tutorial. Anyway, a personal comment before that. You might have noticed that you don't see me in the bottom right corner anymore in this video. I want to try this out. Of course, it's funny and very personal when you see me talking, but I mean, this course is not supposed to be about me. It's about Java. I want you to learn Java. And so it might be distracting and I want you to focus on the code. So in this episode, I removed it, and please send me your feedback and let me know what you prefer. And then we see how I continue. Okay, anyway, enough about me. Now back to the code. So last time we talked about arrays. Actually, in this line, we define an object of type person array. So in this line, we have not defined a single person, but an array which has space enough for 4 person objects. Also, I spotted this actually is, as you see, it's okay, but it's not so nice. Actually, I would ask you to put it here. Both variations work. It's just that this actually is so much more readable, because if it's here, you can directly, when reading from left to right, you directly realize this is not a person object, but it's a person array object, which is a big difference, of course. While if it was to the right, I don't even want to put it there anymore, you might start reading and might think, oh, this is a person, when it's not. So very important, always put it here. Thank you. And sorry for the confusion. And in the next line, I said add space, which starts counting at 0. Also sorry about this, but it was not my idea. So they start counting at 0, and we create a person object in here, and the reference to it, not the object, but the reference to it, will be put into the array at position 0. And so on. We iterate through each and every position and put a person object there. I think I also showed you that you could also say null, which means put null there, which by default is already there anyway. So we could also just remove it. If you iterate through the array with, like here, the for loop, which we defined in the tutorial before, the last one, no, here it's okay because we put the person here. But if you would be like accessing the array and this iterates through all the positions, this would actually cause an error if we haven't set a person here. So be careful. We don't want errors. This is not so nice. But I just wanted to know you that it's possible to have an array that has like an empty space. Let's call it like this. But evil things could happen when you like work on that array then. And with this, we already at the for each loop, which I also talked about in the last tutorial, which, as you see, is so much easier to write, faster, and I think even easier to read, because it's just take the person's array and go through it one by one, and then for the first person call this method, and next. For the second person, call this method next. For the third person, call this next. And at position 3, the fourth person, tag the person, the reference, and on this reference call hello world. So on each of them we can do something. Okay. Yeah, and we also talked about length, which is a public attribute of the person's array or in any array, so also like a string array or whatever, int array. They all have by default this length attribute. Actually, it would be so much nicer if it was a method, but this was introduced, I guess, with Java 1 or so, so it's really a thing from the past, and yeah, every human makes errors sometimes, and this was not so nice, but now we just have to live with it, because it violates the encapsulation a bit. I think I shortly talked about this in one of the earlier tutorials. So you just have to know this dynamically returns the number of positions that we have here in our array, which here in this case is 4. Okay, and we don't, in the for each loop, we don't have to do this. This is automatically done under the hood by Java for us, so this is so much easier. Okay, and now I want to further extend my explanation about arrays, because there is one more cool thing, and it also makes it easier for us. We can actually even on the fly, Alt 5, Alt 6, well, this is auto-completed by my IDE already, persons2 equals 2. And now I do something new. I say curly brace. This is Alt 8 and 9 on my Mac, by the way. And see, there is no red marking anymore. This actually also works. So what does that mean? This actually is a shortened form. And this says there should be an array. And we don't have to say a specific size, because the size is automatically calculated. Because the brackets are empty, this means empty size. That would be the same as saying 0, which of course doesn't make much sense, but just technically it's possible. So, and we can now fill this array. So, and we don't have to set the size. This gets calculated automatically. So I'm just copying. I can also put here null if I want to. I can also create a new object. Let's call it my person. Sorry. I can also, just to show you what's possible, define a variable of type person and then assign null to it. We already talked about null, which is like nothing, and put it here. So this actually is the same like that. And I mean, I want you to also see this. What this does is, it does not, or what is not is, it does not like combine this array and that array. Instead, it says what you have at position 0 of this array, which in our case is this person object. Take the reference to it, and the reference copy it here, which means this position, as well as later on persons 0. So later on, after we have defined the array, if we say person2 0, that will be exactly the same as persons 0, because they both point to this object in memory. All this is a bit complicated, I'm sorry. I hope you can follow me. And I will do a specific tutorial only on memory management and show you how things look in the memory. For now, I just hope you can follow. If not, it's not so important. I mean, we're talking here about arrays, and what I want you to understand is, like, this is an array and this is a way of defining the array, and the specifics about the memory, don't you worry, we can go in more detail later, and you will understand this very soon, I'm sure. Let's do the same trick again, just with a different position. You can actually even do it twice or any number of times. You can take another one, order doesn't matter. Let's put this, well, we can also remove the null, put it here. So yeah, you can do what, and you can also do it on the fly. You can say new person. Now there is now a little difference, which is this object that I defined here. It sits somewhere in the memory, and my array persons2 has a reference to it. Outside of my array, there is no one who has a reference to it, which we can change after we have defined it. We could also say I have now to count 0, 1, 2, 3, 4, 5, 6. I hope I have counted correctly. If not, imagine I had counted correctly. Okay, so I said 6. So at position 6, we can now copy this reference, and I can say my, let's call it secret person, or let's call it just VIP. So my VIP, now I have a reference to it outside of the array. So I created it directly on the fly in this line, together with the definition of this array. And later on, just for the sake of it, I assigned it a variable, which we then also can use and work on it, like hello world. What you can also do is say person2 at position 6 dot hello world. So you can really work with the arrays at specific positions just as if you had a variable. It's exactly the same thing, even though it looks a bit awkward. But yeah, you get used to it. Okay, anyway, I think this is a very handy short definition, because see how much shorter this is. Here we defined just 4 persons, an array of 4 persons, and this was actually 5 lines. Now in just one line, we have defined an array of 6 positions, and we have filled it, and this is all in one line, and I think it's still readable. I mean, readability is the most important thing. So it's not about making something short. It's okay to make it short if it keeps being readable, or if it's even more readable. Then it's okay. Okay. And I might also, while already introducing new stuff, I might also introduce you to final. Final is another variable modifier. We already talked about public and private and static. Now final is something new. Final says, like, log in this variable. I don't want anyone to poke around with that variable. So if I later, after saying final, say this, Java will say, oh no, cannot assign a value to a final variable person2. So this is like a protection. As you see, we have to say final. So this is one more keyword, and this is one more keyword to read. This is one more keyword to write. And so I would only do it if it makes sense for a reason. And if you have code that is just like here, 2 lines, I mean, while doing that, I would assume you know what you do, and you wouldn't like put this to null if you don't want to, just one line later. Where this does make sense is if you have something like some constant values, some status values. For example, you could have a process, a program that operates on some values, and then you want to remember the state that your process is in. Okay, let me give you an example. So for this we would again define an array, but we would do it in the class, on the class level. And we would not do it for the objects, but for all objects of the class. And this of course is static. So static, we talked about this already, means we have just one of this type for all the objects. And now final. So static and final, they're really close friends. They're used together very often. And now let's say string, because I want to have a string, but actually I want to have a string array. And we set the braces right after it so that we see it's not a string, it's a string array. And I call it my state values equals, and then the curly braces again. And now I can say like pending and processing and processed. I could of course, brackets missing, add many more. Just for now, I have a short example. So this is what we could do. Something is wrong here. Yes, comma. Okay, and this means now, and I've also, I did something and didn't explain you why I did that. So far, all the variables that we defined, we had in lowercase letters. Here I use the uppercase letters and the underscore. This is also again a best practice, because like we would use the static final somewhere down here in the code, and you see now the definition is gone, we don't see it anymore. And so that a programmer working in here knows what you're working on here is static final, so I don't want you to touch it, I just want you to read it. Therefore we use the capital letters and we separate them with the underscores, so we don't use the camel case. And then we could again, of course, iterate through these values. So let's do the for each loop. Let's say string my state, or just state, and then the curly braces again. We could say if, we already talked about if, state has a certain value. Well, actually, we can't on a string say equals. This is not going to work properly, because the equals is working on primitive values like int, and it's comparing the value that is directly in the variable. Oh no, sorry, I'm going really complicated. I don't want know if I'm making it too complicated, but now that I already started, I might just as well continue. What we have to say for if we want to compare two strings is equals, and so we can compare that to some other value. So we can do it state equals and then a string, some other value. So this is the equals is a method that is directly given to us from the string class that we haven't written, but we're using it from Java. And this says compare this string to some other something, blah 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 blah. Okay, and if they're both the same, we could do something, and then we could do this a number of times for each value. So we had, as far as I remember, something like pending and processing, and of course uppercase and lowercase make a difference here, and I think it was processed, but I mean this is just an example, so it doesn't really matter that much. So, and then we could do something, call a method, and here we would call a second method and a third method and so on. Okay, but actually this is a lot of code. So there is a faster way doing that, and this is the switch statement that I also promised to talk about. And second, the string here is also not so nice, because you could change it anytime. You could say in here state equals to blah. And of course with just a few lines, I'm sure no one would ever do that, or hope. But imagine we only have always here very short examples. We could have like a very complicated code, hundreds if not thousands of lines, and we could like call other methods, forward this to other classes, and then if someone in some other class like changes your value, you might not notice, and you don't want that. You want actually to have the value final, but this with final doesn't work, because final only protects the variable. It does not protect the value in here, which you can change anytime. And for this, we have the enum. The enum allows us to define an enumeration. Well, okay, now let me just remove that. Or we can keep it for the time being. But let's jump over. I have prepared here a class. Well, actually it will be our enum, and it will not be a class. Okay, so far I have just set package. For lesson 10 I have set lesson 10, and now, like you know it, with the class we would say public class logging level, and then braces. But this time we're not doing a class, we're doing something a bit smaller, and this is the enum. And now this is obligatory. You have to start with the status definition. And it's not a string, so we don't need the double quotes that we would have for the string. Now this is really a value, enumeration value, which we define of our enum. So we program our own type, and we already program the allowed values. Pending, we had processing, I think we had processed. Yeah, and then we end here. And now we have defined an enum, and we can use that. Let's go back to our test. Let's say logging level, or let's call it my state equals to logging level pending. So this is a lot looking like static, and this is already how it came, because now we can use these static values, we can also iterate over them, but we cannot change this. I mean, we cannot, of course we can change it, but we can only change it to the allowed level, allowed statuses that we have defined beforehand. We can set pending, processed, and processing. The order here is different, but still the same. It can only have one of the three values. We could not say here something crazy, because it's not a string. We can only use the values that we have defined here. And this is really helpful and makes also our code more readable. Now we can again iterate through this enum. In this case, it's a bit more complicated actually, because we have to call a method which is called values. This method will give us something like an array of all the allowed values in here: pending, processing, processed. And then, of course, it's not a string anymore. We say, let me also remove that. And then we can do the same. Now, it's okay to say equals. See, this works. Of course, it does not make sense. I mean, a string will never be equal to an enum, but it's perfectly fine. You may compare any object to another object. Of course, it makes more sense to say equals dot, for example, pending, and then here processing and processed. So let's put processing, and here let's put processed. Okay. But this is not so readable, and we don't need equals here. This is so cool. Actually, for an enum, we can do the comparison just with the double equals again. This does work, because yada yada yada, Java does magic under the hood. So for now, just believe me, it's working. Because this is not an object. This is a static value. Okay. Well, let's just remove this. Okay. Now, you see, I think it already got so much more readable and shorter. But however, there is still a shorter form, which is the switch statement. However, we will not do this today. We'll do this in the next tutorial, the switch statement, because I think otherwise it's just too much for one tutorial. Now we talked about arrays, repeated the for each loop. Yeah, and I introduced the enum, which has here this values method. Actually, there is much more an enum can do. Maybe I should show you this one. We can also add these brackets here. Let me do this for a moment. And now we can put values in here. So what is this going to be? And I'm adding a constructor, which must be private. Let me check if it may be default, but I think not. Well, let's just try it. Seems to be working so far, but I'm sure it may not be public. Yeah, this is not working. So default visibility seems to be okay, even though I think it's a bit awkward. And now, see this. It says the int cannot be applied to this constructor, because so far the constructor is empty. Because what happens is this is calling the constructor. So let's put the int here, and now it's working. So having the constructor here, you might also see I was kind of lying to you. Of course, this is an object, but it's just that for specific reasons, I don't want to go in detail, we can still do the comparison with the double equals here. Okay, anyway, so we have a constructor, and let's now assign the I to some other variable. Of course, you see this doesn't make sense, assigning I to I, and we have already had that, this dot I. Now, of course, I have to define it, and let's make this private, int I. So now it's working. Oh, I don't like it. I want this private. This is just what you would do. Okay, and then, I mean, this depends what this means. Could be some code of some form. So let's have a method that returns public code. And this would return the I. So this enum is really powerful. It allows us, int is missing, to have methods which return something, but it has these static values that we can iterate over and that we can only choose from. You could also think of a traffic light with like red, yellow, and green. You can also, of course, have more values here, any number. Actually, you don't have to have the enum in its own file. You could directly on the fly define it inline in a class. I would just not recommend you to do so. I mean, for every rule there is an exception, and find out these exceptions for yourself, but in 99% of the cases you would be better off having it in your own class. So yeah, there's much more actually that you can do with an enum, but I think we already this tutorial is already a bit long, and I think I want you to digest this for now. We can further extend this anytime, of course. So that's the enum with its constructor and a public method returning the I. You can also have more parameters in here, like a string. But if one of them has it, then all of them have to have it, and every parameter appearing here has to appear in the constructor. String, some string, or let's just say s. You may use it, but you don't have to use it. But usually, of course, you would use it as equals s, and then something. Yeah, okay. So I think that's enough for now. In the next tutorial, I'm pretty sure I'm going to show you the switch statement, because this is really cool for iterating over these enum values. Then the code gets much shorter. Okay, so thank you for watching, and see you next time. Wait, there is one favor I would like to ask from you. Please take a second to leave me a comment below this video. That would make me happy. Thanks a lot, and see you next time.